Lesson 7, Algebraic Expressions, the commutative and associative properties. In this lesson, you will identify expressions using the commutative and associative properties. Exercise 1. Susie draws the following picture to represent the sum 3 plus 4. Ben looks at the picture from the opposite side of the table and says, you drew 4 plus 3. Explain why Ben might interpret the picture this way. Okay, so Susie drew 3 plus 4 because there's 3 bricks or blocks plus 4. However, Ben is looking at it from the other side of the table, and he says, well, wait a minute, that's 4 plus 3. So if you think about it from the way that Ben is seeing it, if he's on the other side of the table, he's seeing it the opposite way. He's actually seeing what the picture would look like if you were to turn it. So think about if you turned your book, which you can actually turn your book all the way around 180 degrees, he's looking at it like that, like if you lifted it over. So in his opinion, he sees 4 blocks and then 3 blocks. So that's why in his eyes, he's seeing 4 plus 3. Okay, flip your book if you're not sure what I'm saying. Turn your book all the way around. Okay, so like that versus like this. That's what would happen if it was on the opposite side of the table. Okay? So in terms of explaining why Ben might interpret the picture the opposite way, Ben is on the opposite side of the table. So he sees 4 plus 3 blocks, or the blocks in the opposite order. Draw a picture of what that would look like this. So he's going to see 1, 2, 3, the first 4. Okay, so here's the 4 bricks, or blocks, whatever you want to call them. And then from here to here, he's seeing 3 more. Like that. So that's why he sees 4 plus 3. The opposite way that Susie was seeing them. 3 plus 4. Okay, Susie adds more to her picture. The picture now represents 3 plus 4. That was the original picture. And now she adds 2 more on to the end of it. How might Ben interpret this picture? So again, I think he's still going to see the picture in the reverse order. He's going to see it like this, which he's going to see the 4 plus 3, but he's going to add the 2 on the front of it. Okay? He's going to see it in the reverse order. What I did was, because he's on the opposite side, I just rotated it. So I think he's going to see 2 plus 4 plus 3. his 4 plus 3 with 2 added to the front of it. Just to be clear why I put parentheses and why Susie put parentheses on it, on the 3 plus 4 or the 4 plus 3 is because that was there originally and then added 2 more. Susie added 2 to the back of it, and I think he's going to see 2 added to the front of it. And the grouping symbols, the parentheses, means do that part first, or in this case, that part was already there first. Okay, so taking the original picture that Ben was seeing, there was 4 there, and now he's going to add 2 on to the beginning, and then 4. 1, 2, 3, 4. Might not very equal. You guys can do better than I can, and then 3 more onto the end of it. Okay? So 4 plus 3 was the beginning, and then 2 onto the end of it. Okay, so I think, so Ben will see 2 plus 4 plus 3. Meaning 2 added to his original 4 plus 3 at the beginning. The opposite of Susie, because he's on the opposite side of the table. Okay, exercise 3. Susie then draws another picture of squares to represent the product. Product means times. Three times 4. Ben moves to the end of the table and he says, from my new C, the picture looks like 4 times 3. So the way that we represent, okay, next thing it says, what picture might Susie have drawn? The way that we represent a product, so addition is all the blocks in a row. A product is kind of like the floor. Like if you wanted to count how many tiles were on the floor, you would count up one side and you'd count up 2 sides. And then you would multiply them together and that would tell you how many are all through the middle of it. So 3 times 4, for example, so we'd have one big square like the classroom, but one side would have 3. So 1, 2, 3. And then the other side would have 4. So 1, 2, 3, 4. And then to find, so we'd have 12 altogether because 3 times 4 is 12. Just continue this. And so this is the way that Susie would see it. But, so for example, let's say that Susie is sitting right here. Now originally Ben was across from her, but they're saying that Ben took a new seat and he moved next to her. And now it says Ben moves to the end of the table and he says from my new seat. Because if Ben is still right across from Susie, he's still going to see exactly the same thing. So now Ben is going to be across from her and he's going to see 4 times 3. So from Ben's point of view, now he's actually seeing the 4 first. So to him, the triangle, or the triangle, I don't know what shape I would in kindergarten, the rectangle, Ben is actually seeing 4 first, and then he's seeing 3. So now 4 would be over here from Ben's point of view, and 3 would be on this side. Okay, so with Ben, this is going to be 4. So we have 3 lines going across here, making 4 squares, and 2 going down, making 3. So now it says 4 times 3 to Ben. Okay, so that's the difference between their pictures. So Susie is seeing 3 times 4, and Ben is seeing 4 times 3. Do they see the same answer? Yes. Okay, the next question it asks us is the quantity 3 times 4 times 5 equivalent to 4 times 5 times 3. Okay, to show that they are the same, let's think back to order of operations. So when we have 3 times 4 times 5, parentheses, remember, say do this part first. So that would say do 3 times 4, which is 12. And then multiply it by 5, which 12 times 5 is 60. So the parentheses over here are saying let's do the 4 times 5 first. And then multiply it by 3. Well, 4 times 5 is 20, and then 20 times 3, that's 60. Okay, so is the quantity equivalent? Equivalent means, the word equivalent, that just means equal. So they're asking us, is it equal? And the answer is yes. And that's because multiplication doesn't matter what order you multiply the numbers in. If they're all the same numbers, it is going to come out equal. So yes, the expressions are equal. The order that you multiply the numbers doesn't change the answer. Okay, so there's 4 properties of arithmetic. The first one, you need to finish out the sentences, the part that's in red. The first one is called the commutative property of addition. Excuse me. And this one says if you have 2 numbers, we're going to call them A and B, and they're real numbers, then it doesn't matter what order you add them in, A plus B is equal to B plus A. So for example, 2 plus 3 is going to be equal to 3 plus 2. Right? They're both 5. Doesn't matter which way you add the 2 numbers, you're still going to get the same result. This is called the commutative property. Another way of saying the commutative property, another way of thinking about it, is that order doesn't matter. So I like to call this one the order property. Another word for commutative. Think about this as order. Sometimes that's helpful to think about that way. Now, the associative property of addition, this is when you have 3 numbers. So in general, we're going to call them A, B, and C. If you have 3 numbers, then it doesn't matter what way you add them, the results are going to be the same. So if we have A plus B plus C, it doesn't matter if I add B and C first, or if I add A and B first, the result is going to be the same. So for example, if I have 2 plus 3 plus 4, that result would be 9. It wouldn't matter if I added up the 3 and the 4 first. 3 and 4, oops, forgot my addition sign in there. It wouldn't matter if I added up the 3 and the 4 first. That would say 7 plus 2 is 9. Or if I added up the 2 and the 3 first, that would be 5 plus 4 is 9. It doesn't matter what order you add them up in. You're still going to get 9 no matter what. The associative property, I like to think of that as the grouping property, because that's what parentheses do. It tells you what part you're going to group. And then these same properties are true for multiplication. So the next one's called the commutative property of multiplication. So that one says if you've got two numbers, it doesn't matter what order you multiply them in, you're still going to get the same result. Okay, so for example, 2 times 3 is equal to 3 times 2. It's 6, no matter what you do. Okay, again, commutative, I think of that as order. You can change the order around and still get the same answer. And again, the associative property also works for multiplication. And again, I think of this as the grouping property. Doesn't matter what order you group them in, you're still going to get the same answer. Okay, I think you think of this as the last example that we did with the two people. So for example, 1 times 2 times 3. It doesn't matter if I multiply the 2 and the 3 first. So 1 times 2 times 3. This one would say multiply 2 and 3 first because 2 and 3 are parentheses. So that would be 6 times 1. That's still 6. Or it wouldn't matter if I multiply the 1 and the 2 first. That's 2. And then multiply it by the 3, which would make it 6. No matter what, the answer is still going to be 6. Okay, so those are the 4 properties. So now what they want us to do is look back at the first 4 exercises and tell which of these properties are being demonstrated. So we've got the associative property of multiplication, the commutative property of multiplication, the associative property of addition, and the commutative property of addition. So if we go way back to the first example with Susie and Ben, this first one with Susie and Ben looking at adding up 3 and 4, or 4 and 3, that would be an example of the commutative property of addition. That's the commutative property of addition. Okay, so this is the first example today with Susie and Ben looking at the blocks, and it didn't matter what side of the table they looked at them. That was an example of the commutative property of addition. Now the next one, where they added 2, it didn't matter if they added 2 to the front or to the back of what they already had. This one was an example of the associative property of addition. Okay, so that was what this one was an example of. And this one was the commutative property. Okay, so each of these examples was showing you one of those properties. Let's see, the third example, when we did the multiplication bricks, This one was the example of the commutative property of multiplication. A little bit on spelling that one. The commutative property of multiplication. Okay, so this one was an example of the commutative property of multiplication. And then the last one, where we showed that it didn't matter what order we multiplied, we still came out to 60. This one was an example of the associative property of multiplication. So this one was an example of the associative property of multiplication. Okay, so now I'm going to show you how we're going to actually use these properties today in our work, which is what we're going to look at kind of how you're introducing geometry next year. It's called proofs. And we're going to be stating which property is happening. Okay, so real quick, this is a statement showing you the difference between the two properties. Equivalent expressions. Equivalent means equal, remember. Two expressions are equivalent if they equal the same number. So this first one is they are equivalent. 2 plus 3 plus 4 is the same as 4 plus 2 plus 3. Order doesn't matter. But the bottom one is not equivalent. 2 plus 3 plus 4 is not the same as 2 times 3 times 4. Okay, so pay attention to the signs. Is it an addition problem or is it a multiplication problem? Alright, so this is what we're going to be looking at. Using our 4 properties of arithmetic, we're going to make what we call a proof, showing which expressions are equivalent and stating what property is being used. Okay, so if you look at this first one right here, to go between the properties, we're going to tell which property we're using. And this is where those extra words come in handy. Are we using order or are we regrouping something? So in this case, we have 3 numbers, and we're saying 3 plus 4 plus 2 is the same as 3 plus 4 plus 2. So in this case, this is just changing the grouping around, and that would be the associative property of addition. So associative property of addition. Okay, so let's look at the next line and ask what happened. So now if you'll notice in this one, from here to here, the order changed. And when order changes, that's the commutative property. So in this case, this would be the commutative property of addition. The reason why these are of addition is because adding is what's happening. Okay, and then the last one, they went from having no parentheses to having parentheses, which means grouping. So again, this would be the associative property. Everything's in the same order, so that wouldn't be changing the order around, which means no commutative property. They just decided to group the 4 and 3, and that says do this part first. So that's why this one's going to be the associative property of addition. Okay, so that's one example of how we're going to be using these properties. So now example 2, I think this one's just multiplication now. Okay, so we're going to look at one line to the next. So you'll notice here the difference from the first line to the second line is they took parentheses out, which means they're changing the grouping. So that's the associative property. But this time it's the associative property of multiplication. Okay, if you look from line 2 to line 3, order changed. It goes x, y, z, z, y, x. So the order changed. So order changes. Whenever the order changes, that's the commutative property. Of multiplication. And then we went from no parentheses to parentheses, so that means grouping has changed, so that's associative property. Of multiplication. Okay, so that was 2 kind of quick examples. The next one's a little bit bigger example, and now not only can we use the words commutative, associative, but we're also going to use distributive. Okay, so commutative, associative, we're also going to use distributive. So for commutative, you want to look for, commutative means that the order changes. Associative, you want to look for grouping. Sometimes it's grouping or ungrouping. And distributive, remember that's when it's something like A times B plus C, and then distributing it. Okay, so in this instance, that's actually the first thing that's happening. 2 times 4, 2 times x. 2 times 4 plus 2 times x. That's actually the first thing that happened. So that's our first property, distributive property. Now in this particular instance, each line, sometimes you get finishing a property. So like in this case here, they finished distributing because 2 times 4 is 8. So we're going to clean that property up a little bit. So we're still distributing. They didn't do it in one step like I showed you yesterday. Okay, so now, right here, the order changes. So that would be our commutative property is happening. And technically it's the commutative property of addition since it's adding 2x and 8. Okay, next, if you'll notice, they added parentheses around the 8 and the 3. So that's grouping. Okay, oops. They added parentheses here, so that's grouping. So that would be the associative property. Of addition, technically. And then all of a sudden they came up with the answer to 8 plus 3. So that's just finishing the associative property. So every time they find an answer to something, that's finishing the property that they were on. And then all of a sudden they just took those parentheses away from the 2 times x. This one's the trickiest one of them all. They finished that property up right here. And that actually would have been something I would have done at the very beginning. That's this part right here. So they finally finished the distributive property. See, if it were me, I would have just taken this distributive property here. And I would have just said that's 8 and that's 2x. But they did it in steps. They finally got the 8 on step 2, and they finally got the 2x on the last step. So they kind of took forever to do that distributive property. So that's why we've got the distributive property written down 3 times. And then the last step here, they turn the order around. Okay, so this is order. So that one's pretty easy now. That's the commutative property. So keep yourself looking at these hints up here. Commutative is order, associative, it's grouping, and then distributive. I know you learned that last year, and we just re-looked at that again this year. Okay, so that's the kind of things you're going to be looking at this year. Distributive property comes up again today, associative is new, and commutative. Okay, and that's today's lesson. When you finish the notes, make sure you work on the assignment and then turn that in when you're finished.